Kotlin is described as an object-oriented language, but it is also a functional language in the sense that we treat functions as first-class citizens. Now, there's many arguments and debates over what exactly is considered a functional language or non-functional language. Is Haskell the only pure functional language? For myself, and I think many others, the fact that you can treat functions as first class and treat them as primitive, so to speak, objects to kind of like pass around, work with, etc., it makes it kind of functional. So to all practical aspects, you could say that Kotlin is a functional language if you stick to that kind of philosophy or way of thinking. And we're going to see now more about the functions that we've been using and how to declare functions and how to work with them and how to interact, etc. So let's dig in. I've created, in the functions package, I've created a file called functions. And we're going to start looking at the different functions here and how we declare them. So basically, because the fact that we have top-level functions, which means that we don't need to create any kind of static class that then holds the actual function, we can just start to type functions in the file. And we've seen this when we've created the main function. Now I'm going to create a function called hello. And all this is going to do is print hello. So notice that, let's go ahead and also create a main function so that we can use this hello. So we're calling the function. Notice that I'm not declaring any parameters here. So it's the word, keyword, function, and then hello, the name of the function, brackets, and no parameters in this case, no arguments. And there's no return type either. Now, if I want to invoke it, I just do hello, open, close brackets. This function doesn't have a return type. We see that it's basically printing out a line and there's no actual return type. Now in Kotlin, this means that by default it is returning void, which in Kotlin is unit. So I can be explicit about this and say :unit, and now I'm declaring the actual return type, which in this case is unit void. Unit is similar to void, but it's a little bit different. In fact, if we navigate to unit, we can see that it's an object, and we'll see what this keyword object means later on. But for now, note that it is actually kind of like an object that we can compare to. So I can actually say if the function is returning unit, then do something. So it provides us with that power. And we've seen many times that in the past when we've done the conditionals that when we print out the value, it returns kotlin.unit. So in this case, hello is returning void, as I said, unit in Kotlin. Now, there's another type of return value, which is called nothing. And we can use this in special cases where we want to actually say, for instance, that function doesn't return a value, and it can actually throw, for instance, an exception. So it's a value that never exists. So let's say, for instance, I have a throwing exceptions, and I can say nothing. And then I'll say throw exception. This function throws an exception. If we navigate to nothing, we can see that this is a class with a private constructor, and we'll dive into the syntax later on. So this is different to unit in that nothing, you can use it to represent a value that never exists. For example, as I said, if a function has the return type of nothing, it means that it never returns. It actually throws an exception. So if I want to return a value, let's say that I want to create a function that returns a 4. In this case, I want to return an integer. So I can say return integer and then do return 4. So now I'm declaring a function that returns 4, and I can assign this to a value. So let's say to a variable. So I say returns 4. So we can explicitly declare the type that a function is returning. Now, much like when we're declaring variables, there is type inference for return types also. So in this case, I could just eliminate the return type and say that this returns 4. Now, to pass parameters, we've already seen here in the main function that we have an example of a function that actually takes parameters. It's got an array of strings, and if I want to create my own, I could just say, for instance, fun taking string, and we'll say name string and print line name. If I want to call that, I simply pass in the value, so I say taking string some value. And this is something that we've already seen. If we want to declare multiple parameters, we can simply do that by, for instance, creating them, separating them by commas. So let's create a sum function that takes an integer and another integer, and it's going to return an integer. So we do return x plus y. Now, similar to how the variable declarations can have type inference, function value, return values can also be inferred by the compiler. So in this case, I'm saying that the sum is taking two integers and returning a value. But given that the compiler knows that this argument is an integer and this argument is an integer, I can actually remove this. This example here, what we're doing, we're just returning x plus y. And we can make this as a single expression function. So basically what that means is that we can eliminate the body and we can just do x plus y. So what this is doing is returning a function that is the sum of x plus y, which is the two arguments. Now the compiler, given that it knows the two types being passed in, x and y, it can automatically infer the return type. So we can make this even shorter by eliminating the return type being explicitly mentioned. So this is a single expression function in that it's basically a function that has a single expression that's returning a value. So we can make it even shorter than having to declare the actual body.